Hello everyone, this is your little summary of graphs of trigonometric functions. And just a quick reminder, so the domain of a function is a set of all x values for which the function is defined, and we'll be looking at the domains of the functions below, and we'll also be looking at the ranges. The range is the set of all possible y values the function takes, given that x can be any element in the domain. In other words, it's the interval on the y-axis from the lowest to the highest value. How I often think about the range is if you were to squash a graph horizontally back to the y-axis, what are all the y values you'll hit? There, the graph I've given you now is y equals x squared. It's not trig at all, but the range of y equals x squared is all y values that are greater than or equal to 0. Another way of describing the range is all the y values along the curve. Okay, for sine and cosine graphs here, suppose f of x is a function. The midline of sine x is the horizontal line which lies halfway between the highest and lowest points, and the amplitude is the distance between the midline and the maximum and minimum values of the graph. Just to look below, the midline here of this graph, which is y equals sine x, would be y equals 0, and the amplitude is the distance from y equals 0 up to the top or down to the bottom, which is 1. Amplitude is there and the midline is there. You don't need to worry too much about those terms, but just knowing them kind of does help. Okay, so the domain of y equals sine x, which is given above in green, is from minus infinity to infinity, or all real numbers. You can put any number into the sine function. Then the range, if you think about squashing that back to the y-axis, all the values you'd hit would be everything between minus 1 and 1. So these square brackets mean that y is greater than or equal to minus 1 and less than or equal to 1. And then the period is, actually I skipped it up here, the period of function f of x is a positive number a such that f of x plus a is equal to f of x. In other words, it's the shortest distance along the x-axis after which the function begins to repeat itself. So you can see there that you have a whole wave of sine between 0, this is 2 pi. So you have a whole wave of sine between 0 and 2 pi, and then the wave just continues on to infinity. So the period is 2 pi. These facts, the fact that the period is 2 pi for sine x, that the range is between minus 1 and 1, those facts you do need to know. They'll come up over and over again. Okay, now everything I'm going to do with the movement around of these curves will relate to sine x, but everything I do, it has the same impact when you're dealing with cos x. So here on the graph below I have, now in green I have sine x already. Okay, so that's the sine x that we're familiar with. Okay, so here is sine x, the wave between minus 1 and 1, and I wanted to have it there in order to compare it to the blue one above, which is the function sine x plus 1. So what do we do to sine x to get sine x plus 1? We move all the y values up vertically by just 1 unit. That's true actually of any function. If you take the graph of f of x and you want to graph f of x plus 1, just you vertically shift everything upwards by 1 unit. So you can see now that the range is between 0 and 2. Okay, there are all the y values along the blue curve. The domain is still from minus infinity to infinity, and the midline has moved up to 1. And that's reflected actually in the plus 1 here. Okay, that corresponds to the midline. And then the range is from 0 to 2. Now, if I just gave you this function sine x plus 1, how you'd get to the range of that starting with sine x? Well, you know sine x is a range from minus 1 to 1. And then if you add 1, excuse me, you add 1 to the lowest part and to the highest part, and that's how you get the new range. Just to tell you, if you didn't have the graph in front of you, excuse me, how you might get the new range. I'm not going to focus too much on the amplitude. So shift the graph of y equals x sine x up by 1 unit to get the graph of y equals sine x plus 1. And then similarly, to get y equals sine x minus 2, you just take the graph of sine x shifted down by 2 units. Okay, the domain is still the same, the period is still the same, it's a vertical shift, so nothing has changed with the period. And then the range is now from minus 3 to minus 1, because again, if you start with sine x having a range of minus 1 to 1, that's what I mean when I say this keeps coming up. If you're looking for sine x minus 2, you subtract 2 from both ends and you end up with a range of minus 3 to minus 1. Okay, so that's what happens when you add a number or subtract a number on the outside of sine. On the following graph we have, in blue we have twice sine x, and once again what you have there in green is sine x. Okay, so sine x is in green. And then in blue here we have 2 times sine x. So it's not a vertical shift, it's actually a vertical stretching away from the x-axis, because all the previous y values of sine x get multiplied by 2 to give you your new y value, okay? And it depends on what the y value was to begin with, how much the new y value increases by. Okay, so when the y value is 1, the new y value becomes 2. Okay, and then when the y value is 0, it just remains 0 when you multiply it by 2. So the graph of y equals sine x, if you stretch that graph away from the x-axis by a factor of 2, you get the graph of 2 sine x. And then in terms of range, if we know that the range of sine x is from -1 to 1, 2 times sine x, you multiply all those values by 2 to get a range of -2 to 2. Okay, midline of y equals 0. Okay, and then similarly, to get the graph of a half sine x, we take all the values of we take the graph of sine x here. This is green is sine x, and if we compress that graph towards the x-axis by a factor of a half, we get half sine x. Okay, so everything's been compressed down to give us that half sine x, and the range then there is from -1/2 to 1/2. Domain is all or. The period is still 2 pi. Things still repeat themselves after 2 pi. Next, if you wanted to graph y equals minus sine x, so you take the y equals sine x graph, and if you start with that and you take all those values and you make them, or you multiply them by -1, which is what is happening when you have y equals -1 times sine x. Well, if they were positive, then they'll become negative, and if they were negative, then they'll become positive, and they'll have the same value. So what you're doing here is you're reflecting the graph of y equals sine x in the x-axis to get the graph of minus sine x. And then if you combined that with another move, so you reflected sine x and then you added 1 to it, sorry, this will be in blue below, you take the blue curve from above here, minus sine x, and you add 1 to it, so it moves it upwards by 1 unit, so you end up with the blue curve below here. And then just in terms of the range there, again, if I was asking you, if you didn't have the graph in front of you and I was asking you the range, so sine x is a range from -1 to 1, minus sine x has the same range. You can see that above, you just change all the signs, and then if you add 1, sorry, minus sine x plus 1, you take that range above and add 1 to both ends to get a range of 0 to 2. And the midline there is 1. Okay, and then I hear it's too confusing if you see the sine x in the same graph, so I just have sine of 2x in this graph. So multiplying by 2 on the inside actually compresses it horizontally. So if you compress the graph of y equals sine x towards the x-axis to get the graph of y equals 2 sine x. And what changes here is the period. So you can see that the range is still the same. It's going from -1 to 1. It's now repeating itself after pi. So the period has changed. So how do we figure this out? How I think about it is, so I know the period of sine x is 2 pi. It repeats every 2 pi. So as x ranges from 0 to 2 pi, you get all the values of sine x and then things repeat. So if you have sine 2x, what value of x will result in the inside there in total being 2 pi? So when is 2x equal to 2 pi? And that happens when x is pi, and that's your new period. Okay, I'll go over that again in the next example. So on the following graph, we have the function sine of a half x. Its period has changed too. So when will a half x equal 2 pi? It happens when x is equal to 4 pi. So its period actually is 4 pi. You need to get all the way out to 4 pi to get a whole wave of sine. Its range is still the same. I haven't multiplied it by anything on the outside here, nor have we added anything. So its range is still from -1 to 1. But its period is 4 pi. So it's a stretching of the graph of y equals sine x away from the y-axis to get the graph y equals sine of a half x. Now, another way of calculating the period, which you might remember, is if you have sine of cx. So when is cx equal to 2 pi? It is when x is 2 pi divided by c. So if you have a number in front of x, the new period will be 2 pi divided by c. That might be something to remember if you like. Okay, now notice first of all, so what I have below here is the graph of y equals cos x. I'm just going to briefly sketch sine x on top here so you see the differences. So cos is just sine shifted over, or sine is cos shifted over, whatever way you like to say it. That went a bit wonky there. So there is sine x, that's 2 pi. Notice cos starts at 1 and ends after 2 pi, it ends at 1. So you get a whole wave going from 1 down to -1 back up to 1, while a sine starts in the middle and ends in the middle. Okay, everything else is the same. Domain is all real numbers, period is 2 pi, the range is -1 to 1. And there's a little note there. There's to find the period. You divide 2 pi by c. And then just a little summary here, conclusions. For graphs of this form, okay, so you see a plus b sine cx. So you get the period by saying cx equals 2 pi, and therefore x is equal to 2 pi over c, and that's your period. Okay, there we are. And then for the range, what I'd do is I'd start with sine. Doesn't matter whether you have cx or not on the inside, the range is -1, 1. And then when you multiply it by b, I'd work through it step by step here. That involves multiplying both ends by b, so that's minus b and b. And then a plus b sine cx, I add a to both ends, a minus b and a plus b. So that's how you get the range. The minimum value is a minus b, the maximum value is a plus b. Y equals a is the midline, if you like to remember that. Okay.